Hello and welcome back. Let's now understand the XOR bitwise operator this time in this tutorial. First of all, let's try to understand the XOR operation. Now, if X is one of the input and Y is the other one, then X XOR Y operation provides output in this way. The conception is, if both of the inputs are having the same state, that means if both of them are either zeros or ones, then the output is always zero. If both of them are having different state, that means if X is 0 and Y is 1, or vice versa, that means X is 1 and Y is 0, then you are going to have 1 as XOR output. Let me just draw that. If both X and Y are 0, we are going to have 0 as output. If X is 0, Y is 1, we are going to have 1. X is 1, Y is 0, we are going to have 1. If both of them are 1, then we are going to get 0 as output. So you can see that if the inputs are having the same state, then the output is 0. If inputs are having the different state, then the output is 1. So that's XOR operation, and that is exactly followed by this XOR bitwise operator. So let's go ahead and see that. So I have these two variables there, X is 5 and Y is 2, and here we go. I can just draw the bit configuration there for least significant 8 bits, and 5 is 101 and 2 is 0010. Now, if we perform this XOR operation there with X and Y, it's actually bit by bit XOR operation. That means each bit of X will be XORed with the corresponding bit of Y starting from the least significant bit. So if this is X and this is Y, then 1 and 0. If X is 1 and Y is 0, we know that it's going to be 1, so the output is going to be 1, and 1 and 0 again going to result in 1. 1 and 0 is 1, and then we have all the zeros there for rest of the 32 bits. So it's 7 actually. The result is 7. The Z will contain 7. Now, how it's going to be useful? It's actually used for toggling a particular bit of a number. If you want to turn 0 to 1, or you want to turn off a set bit to unset bit, that means 1 to 0, then you should use the XOR operation. As you can see that this particular bit was 0, and we kept 1 here, and rest of the bits for Y were 0, and what we get here is 1, and rest of the bit are just same. As you can see that this was 1, it is dropped exactly, this was 1, it dropped exactly, but this was 0, we get a 1 here. Now the reverse thing is going to happen as well. If you have say 1 1 1, that's 7, and you are doing the XOR with 2, then see what happens. It's 1 1 1, we are having 1 and 1, that means the output is going to be 0, so we'll write 0 here, and then 1 0, that's 1 0. So here we had 1, now we are having 0. So if you want to toggle a particular bit, then you can use this bitwise operation. Okay, let's go ahead and run this program and see how that works. Let me just go ahead and run that. So you can see that we had 101, and then I XORed that with 10, that means 2, and then what we get here is 111. So that's how the bitwise XOR works. And as I said, you can use this bitwise XOR for toggling a particular bit. So the general thing is that if you have a variable X and you are doing a bitwise XOR with 2 to the power I, then the ith bit is going to be toggled, Thank you very much for watching this. In the next tutorial, I'm going to talk about the complement operator, the bitwise complement operator.